Black holes are mysterious objects. They are some of the most fascinating and downright strange objects in the universe. They have such strong gravitational pull that anything gets sucked into a black hole disappears forever. Even light cannot escape. One thing to remember is that anything could become a black hole if you were to compress it into a small enough space. How small, you asked? This much. This is Schwarzschild radius, and everything in the universe has Schwarzschild radius. You know what is Schwarzschild radius for Sun? Is 3 km. It means if you compress the Sun into 3 km radius, then it's become a black hole. For Earth, it's just 8.7 mm. But stars, very larger than our own Sun, has a large Schwarzschild radius. During most of the life of normal star, over many billions of years, it will support itself against its own gravity, because the core is generating the energy which is countering the pressure of all the mass trying to pulled in by gravity. Eventually, however, the star will exhaust its nuclear fuel. In some cases, it may be able to support itself as white dwarf star, but the maximum mass of a white dwarf star is about 1.4 times that of the Sun. So what happens when the mass of the star is greater than 1.4 times that of the Sun? Well then, star could not support itself and its core collapse and contract to a single point of infinite density, such a point called singularity, where the curvature of space-time is infinite. In fact, it marks the end of space and time itself. Say one day, you were exploring space, looking for new planets for humans to inhabit, but come across a black hole and decide, why not check it out? But how? So you decide to send a probe into a black hole. Once the probe passes the event horizon, there is no coming back. Event horizon is not a real physical barrier, but rather it's invisible barrier at a particular distance from a singularity. A threshold beyond which the gravitational pull is so strong that nothing, not even light, can escape. Once something or someone has crossed the event horizon, there is no going back. Once they have pierced the veil, they begin the long fall toward the singularity, the ultimate one-way trip. Even if the probe crosses the event horizon safely, there is no way that the probe can send data back because of its massive gravitational pull. So there is no way to know what's inside. So as brave as you are, you decide to check it out by yourself. Before that, we have to choose which type of black hole you should explore. We have many different types of black hole. The most common black holes are stellar. They can stretch to about 15 km across and be as heavy as 20 suns. If you happen to pull toward a stellar black hole, you would be completely torn apart before you even reach the event horizon. As you start being pulled toward a black hole, you'd be moving faster and faster, accelerated by the force of gravity. And here you experience something called spaghettification. The gravitational force of a black hole is very strong. If you fell feet first, your legs would be feeling a stronger gravitational pull than your head, enough to pull you apart. As you descend, it gets worse. The pulling gets stronger. Your body squeezes thinner and straighter until you have been reduced to a thin stream of hot plasma, gobbled up on one final slurp never to be seen again. Spaghettification is a risk with smaller black hole, since they have a much smaller radii. So stellar black holes are not good for you. That's why we are choosing supermassive black hole. So where to find one? Sagittarius A star is the closest supermassive black hole, located at the center of Milky Way galaxy. They have mass of the millions to billions of times the mass of the Sun. With supermassive black holes, as you cross the event horizon, you wouldn't even notice that anything was different. You would feel exactly the same as if you stood on this table and jumped off the table. So you'd be in a free fall for a moment. That sense of free fall would be exactly what you would feel if the black hole was big enough as you cross the event horizon. A gravitational field not only warps space, it also warps time. On Earth, we never have to worry about that, but near a black hole, gravity would be so strong that an observer standing watching you jump into the hole would see something quite strange. They wouldn't see you get sucked quickly into the black hole. Instead, they would see your approach become slower and slower until you reached the event horizon. So to a person watching you fall into the black hole, that would be where your journey ended. You would seem almost frozen in space. The light coming off your body become increasingly redshifted until you simply faded into nothingness. They would never see you cross the event horizon. But for you, of course, everything would be normal. Here inside the event horizon, space and time are horribly broken. The real time travel is possible, so it's probably a good thing that nothing gets out. From outside, you cannot see what's inside a black hole. But when you cross the event horizon, you will be completely enveloped in a light from the surrounding universe. Light that crossed the event horizon also falling along with you. Whether you have survived this long doesn't really matter, as now there is only the certainty to crushing death in your near future. No matter which direction you are traveling inside the black hole, the singularity is somehow always right in front of you. Trying to go in any direction only brings you to center faster. So survive the longest, you must do nothing. Inside the black hole, singularity is the future. The extreme gravitational force inside the event horizon would bend and twist the light, as it gets pulled toward the singularity. Those same gravitational forces would be work on your body too. Now you will experience spaghettification. As you move toward the singularity, your body will squeeze from the midsection and pull and stretch from end to end. By now, your body, distorted beyond all dimensionality, would be crushed into a tiny ball of infinite density, never to be seen or heard again. People have few misconceptions about black hole. Black hole will not actually suck in objects from large distance. A black hole can only capture objects that come very close to it. They are more like Venus flytrap than cosmic vacuum cleaners. For example, imagine replacing the sun by a black hole of the same mass. Then what will happen? You might think that all the planets would suck into a black hole, but no, they wouldn't. Without sun, permanent darkness would fall on Earth, but the planet would continue to revolve around the black hole at the same distance and same speed as they do now. None of the planets would be sucked into the black hole. Our Earth would be in danger only if it come within some 15 km of the black hole, much less than the actual distance of the Earth from the Sun, which is a comforting 150 million km away. Another interesting thing is what happens when two black holes come close to each other. Imagine you are observing two black holes getting a little closer until they started to orbit each other. They would begin pulling matter and gas into a vortex between them. Get comfortable because it could take billions of years for their center to merge. But as the black hole merge into one, they'd wobble a little and settle into a new, bigger black hole. When two black holes collide, they change the shape of space around them. They do it by rippling the space with gravitational waves. Albert Einstein predicted gravitational waves over 100 years ago, but scientists didn't observe them until 2015, when the Advanced LIGO Gravitational Wave Observatory finally detected gravitational waves after 8 years of operation. Even more incredible is the fact that basically everything you heard about black hole in this video or any other video is all about theoretical black hole that aren't spinning because their math is so easier. But since the black holes were born from dying star that was spinning extremely quickly in their final moment as far as we know, all black holes in the universe should be spinning at incredible speed, up to 90% of the speed of light. So in reality, black holes are more mysterious than they usually get credit for. So the question is still remain unanswered, that what is singularity? What really happens when the curvature of space and time diverges in the interior of a black hole? Is there a path to another universe? Is there an object there when matter collects? In the real universe, no black hole contains singularities. In general, singularities are the non-physical mathematical result of a flawed physical theory. When scientists talk about black hole singularities, they are talking about the error that appears in our current theories and not about objects that actually exist. When scientists and non-scientists talk about singularities as if they really exist, they are simply displaying their ignorance. A singularity is a point in space where there is a mass with infinite density. This would lead to a space-time with an infinite curvature, and so a paradox arises. Modern physics is dominated by the two major theories, general relativity and quantum mechanics. Singularities are predicted to exist in black holes by Einstein's theory of general relativity, which is a theory that has done remarkably well at matching experimental results. And on the other hand, quantum mechanics is often called a theory of the very small. In reality, it explains phenomena on a vast range of scales, from elementary particles and their interactions through atoms and molecules, all the way to neutron stars and the supernova that spawn them. So far, essentially all its predictions have been confirmed by experiments. It is the most successful theory of material reality we ever had. But these theories don't conflict with each other. According to relativity, black holes create a singularity, a point in space-time with infinite density that is completely inescapable. And according to quantum mechanics, that's impossible. The problem is that infinities never really exist in the real world. Whenever an infinity pops out of a theory, it is simply a sign that your theory is too simple to handle extreme cases. Black holes may hold the secret to reconciling these two theories in creating a unified understanding of physics. So what's inside a black hole? Well, we don't know. Will we ever truly understand black holes? Really know what's going on inside them? No one knows. We can only see their outside, and our current theories probably get their inside wrong. But it's okay to not know everything. It just means there is still work to be done. It means there are still mysteries to solve and big ideas to think about, which is why humans do science. So what do you think about black holes? Let me know your thoughts in the comments below. Peace.